So AddOptics was founded about 7 years ago with Joris Bisschop, who is the former CTO actually of a 3D printing company called LuxExcel, who was later on acquired by Meta. And when we started AddOptics 7 years ago, we were really thinking about how can we utilize the advantages of the current ophthalmic supply chain, the prescription lens supply chain, and then add the value of what is required for AR glasses to go mainstream. So during those days, when we started out, we were building a mold with a 3D printing process, and then cast the lens with an ophthalmic material. And that already allowed us to use a standard ophthalmic material that is used in current eyewear. However, in order to really reap the benefits of the current ophthalmic supply chain, we had to go a lot further than that. And so that's what my talk will be about today. So as of today, we moved away from 3D printing altogether and really use a process that taps into the current ophthalmic supply chain. Because if you think about it, if you can customize glasses for millions of users, that is something that cannot be easily replicated with other processes. Going into the market details a little bit, obviously you are all very much aware of what is going on in the AR industry versus the smartphone industry, which has been dominant for the past 15 years in consumer electronics, especially with the recent announcement of Meta that really sets a new standard for AR glasses for the years to come. And we believe that the lens will be the center of that, basically of the new platform, so of the AR glasses. And if you look at it, really at the lens is where all the functions are going to have to be combined. So going from the world side all the way back to on the eye side, in between there's a lot of electronics involved. And that also these lenses need to be personalized. So you have your cover lens on the world side, which has to be IPD corrected. Then you have a dimming film, preferably an electrochromic dimming film. And then obviously you have your waveguide display. And finally, eye tracking components that need to be in the stack. And then another very important part, a critical part, is to have it prescription corrected on the eye side. So the current way of doing that is really to stack all of these layers together, and you will end up with a very bulky lens. That's basically too heavy to use as an all-day wearable. And this is where we come in. So what we have been working on is, instead of using a process that starts with a blank and you cut and grind away material for the prescription lens and then stack your components to it, we started by building the lens from the ground up, which means that we build a prescription corrected mold per eye. So for each user, you will have a unique mold. And then this allows us to place the electronic components within the mold and then cast it with an ophthalmic material. And that allows you to go much thinner for the overall stack. So here are some examples, and I do have to apologize to the waveguide experts because you can clearly see the waveguides in there, and I know that's something that they do not wish to see. For us, on the other hand, it's important to show and demo that the waveguide is actually in there. So these are some generic samples that you can also see at our booth. Dimming films, waveguides, whether diffractive or reflective, all within a single unified structure. Besides that, another major advantage is by creating a mold, you also have more mechanical freedom, so that gives you the freedom to integrate the lens into the frame a lot better. And going back to the ophthalmic supply chain, one of the main benefits is the materials that have been proven for many, many years. So therefore, we are proud to partner with PPG, where we can